Continuing 8.1 on page 58. The majority is a number or percentage equaling to more than 50%. We call that majority. More than 50% of the total is called majority. To test a claim about the majority, your null hypothesis will equal 50%. Anytime they say majority, then I will say, well, it's 50-50. A Gallup survey reports that 57 of the 504 randomly selected gun owners support stricter gun law. Test the claim that the majority of owners favor stricter gun laws. Write a hypothesis for this example. What would be type 2 error scenario? The null hypothesis will say that proportion is 50%. It's still the same. The alternative, based on what we see, P is bigger than 50%. Now, it's important that you start putting what the claim is. Test the claim that majority of gun owners favor stricter, more than 50%. So, you need to write the claim so that if you support H0, you would reject the claim in this case. And if you reject the null hypothesis, you would support the claim. The claim could be in either of those. Now, when it says, what is a type 2 error? Type 2, if you remember, is normally when you fail to reject the null hypothesis when it was false. So the null hypothesis was false and you did not reject it. So the type 2 error would be, we conclude the less than the majority of gun owners support stricter gun laws, when in reality the majority does. Which is why it's very important for you to state the sample supports. This group that we picked, the 504, support or does not support. So, your company markets a computerized device to test a patient's mean resting heart rate. Based on the sample result, the device determines where there is significant evidence that the patient's mean resting heart rate is greater than 100 beats per minute. So, the null is going to say the average is 100 beats per minute. But the alternative found that it is greater than 100 beats per minute. If so, your company recommends that the person seeking medical attention. Alright. So, state the null and alternative we did. Which type of error is worst for the company? Fail to reject the null hypothesis when it is true. Type 2 error will be, if you remember, type 2 error is always think the average is 100, but the average is bigger than 100. So here, would you seek medical attention? No, you wouldn't seek medical attention. Do you need it? Yes, because you do not reject the null hypothesis when it is false. So, you do not reject the null hypothesis when it is false. You do need to seek medical attention. No, you don't. That's what the test says. But did you need it? Yes, you needed it. That's really bad. How about type 1 error? Type 1 error is when you reject the null hypothesis. That means, did you seek medical attention? Yeah, because if you reject the null hypothesis, you're assuming that the average is above 100. Did you need it? No, you didn't. So, we will not know 100% if our conclusion of the hypothesis test is true. It's not 100%, perfect process. But we can assign probabilities to make type 1 and type 2 errors when we complete the hypothesis testing. Now, the rest of this, we're not going to worry about. That's not something we're going to do. Now, I'm going to go for 2 problems. I'd like you to try these problems before I tackle them. This is to help you more on the homework. And here they are. Given a test statistics of z equal negative 2.1 is obtained when the claim that p is less than 0.85, the null hypothesis is going to say p is 0.85. Identify the hypothesis testing as being one tail, two tail, left tail, or right tail. Well, if z is negative, then it's going to be a left tail. And this is negative 2.1. If I want to figure out what the p-value is, I will say that's a probability that z is less than a negative 2.1, and I know how that goes. So I want the area to the left. And if it's a z-score, second distribution, I want to go for normal CDF, and I'm going to go from the left to negative 2.1. That's right, that's right, that's right, and find the probability, and here it is. This probability so the probability of that happening is 1.79% chance. Find the rejection region of the test based on alpha equal 0.85. Well, if I want to do a test region for alpha equal 5%, if I set this to be a 5%, I'm going to go for inverse normal. I want an area of 0.055%, 0.1, and I want a left area, right? Negative 1.64. Negative 1.64. So, if my test statistics fall in that region, I will reject the null hypothesis because that rarely happens. If it falls in here, I fail to reject. Now, if the probability is 1.75%, I would automatically, in part B, since the probability is 1.76%, I would reject the null hypothesis. And why is that? Because the null hypothesis is stating things happen due to chance. Well, we need it to be more than 5% to accept a 1.79, I'm sorry. We need the probability to be more than 5% to say, oh, you know what, this is due to chance, you're right. And if we do the test statistics, well, we got a z-score of negative 2.1. Isn't negative 2.1, if this is 0, doesn't that fall in the rejection region? So since negative 2.1 falls in the rejection region, we reject the null hypothesis. And if I look at the second example, here's another problem. Given that test statistics z equal negative 1.9, okay, is obtained when the claim that p equal 1/3, identify the hypothesis testing as being two-tail, one-tail, or, well, p equal 1/3. They didn't specify here, so I'm gonna assume the alternative p doesn't equal 1/3. That makes this a two-tail test. Now, find the p-value. To find the p-value, I need to find this piece and this piece. Well, that would be twice the probability that x is, and this is negative 1.90, is less than 1.94. That is 2 times, and normal distribution, CDF. I want to go from negative, we set to negative 1.90. I wrote it wrong. Not only that, I could put a 2 in front of that, times 2. So that turns out to be 0.0287, so that's roughly 5.7%. Hey, rejection region, if we want a 5% to be upper and lower, because it's two-sided, right? So if this is 5%, that leaves us with 95%. So to figure out the rejection region, the cutoff, I'll say, well, let's go for an inverse normal distribution. We want an area of 0.95, and we want it centered. And that would be 1.96 and negative 1.96. So negative 1.96 and 1.96. Now, if I go for how we should proceed, in part B, the probability is 5.7%. Since that's more than 5%, we fail to reject the null hypothesis. Based on B, z equal negative 1.90, if I look at the rejection region, this is 0. Isn't that in this area? So we fail to reject the null hypothesis. And that's pretty much it.